Talofa everyone. Our lesson for today is for Year 10 Health and Physical Education students. Today, we're going to talk about the effects of regular exercise to the cardiorespiratory system of the human body. In other words, we're going to discuss the benefits of regular exercise to the heart, the lungs, and the blood vessels. As you see on the screen, our topic is given, which is the effects of regular exercise to the cardiorespiratory system of the human body. Next on to that are the curriculum learning outcomes specifically for today's lesson. So by the end of this lesson, you will be able to define cardiorespiratory system and describe the benefits of regular exercise to cardiorespiratory system of the human body. To start up our lesson, let's define these new terms. What is cardiorespiratory system? What is cardiorespiratory system? Cardiovascular and respiratory systems made up the cardiorespiratory system. The question is, what is cardiovascular system? The cardiovascular system, or the heart and blood vessels, are the organs that provide the means to transport oxygen to the tissues of the body. Another question would be, what is respiratory system? Respiratory system, or the lungs, provides the means to gather oxygen when breathing in through mouth and nose and transfer it to the body. So, these two body systems carry oxygen to the muscles and organs of the body and remove waste products, including carbon dioxide. So, there is no doubt that you are going to begin to learn about the keywords of today's lesson. Now, let's discuss the effects or the benefits of exercise to cardio or the heart. There are a number of benefits of exercise to the heart. But firstly, regular exercise helps increase stroke volume at rest. Regular exercise helps increase stroke volume at rest. What is stroke volume? What is stroke volume? Stroke volume is the volume of blood pumped from the left ventricle of the human heart per beat. Stroke volume is the volume of blood pumped from the left ventricle of the human heart per beat. Let's have a look at the picture of the human heart. Before we talked about the heart stroke volume, let's refresh our memory and test our prior knowledge from our previous lesson on how blood circulates through the heart. Okay, as you see on this human heart given on the screen, this is where the blood enters the heart. The blood from the body, or the deoxygenated blood from the body, enters the heart through these pulmonary veins and then transfer it down to the right atrium here. This is the right atrium. After that, the blood then goes down to the right ventricle. And from here, the blood then push up and push out to the lungs through this pulmonary artery here. This purple blood vessel here, this is called the pulmonary artery. So this is where the blood goes out to the lungs, and that is where the blood exchange gases, or that is where the gas exchange occurs. So after the blood releases the carbon dioxide and absorb the oxygen from the lungs, and then comes back to the heart through these pulmonary veins here. So it goes in to the left atrium here, and then it push it down to this left ventricle here, and then push out to parts of the body through this blood vessel here called aorta. Okay, I hope you will refresh your memory about how blood circulates through the heart. Now let's go back to stroke volume. A question that comes to mind is, how do we measure stroke volume? How do we measure your heart's stroke volume? There are two ventricle volumes that are used to measure the stroke volume. The first one is the end systolic volume, and the second one is the end diastolic volume. So the formula of how to measure your stroke volume is that end systolic volume minus end diastolic volume equals stroke volume. Another question that is also would like to ask is, what is end systolic volume and end diastolic volume? The end systolic volume is the volume of blood in a ventricle at the end of contraction. End systolic volume is the volume of blood in a ventricle at the end of contraction. The end diastolic volume is the volume of blood in the right or left ventricle at end load or filling in. So the formula in measuring the stroke volume is EDV minus ESV equals SV. Your stroke volume can be measured using the echocardiographic machine. Your stroke volume can be measured using the echocardiographic machine. Researchers state that the stroke volume increases by about 20% to 50% in the transition from rest to submaximal exercise. Now, we're going to watch this video clip here to help you understand more about the stroke volume.
What is stroke volume? Stroke volume is the amount of blood ejected from the left ventricle of the heart in a single heart contraction. It is the measurement of the difference in the amount of the blood in the ventricle before a contraction, called end diastolic volume, and after a contraction, called end systolic volume. SV equals EDV minus ESV. So for example, if the ventricle has 144 milliliters of blood in it before a contraction and 50 milliliters after a contraction, the stroke volume would be 94 milliliters. It's estimated that the average stroke volume ranges between 50 and 70 milliliters at rest and 110 to 130 during exercise. Elite athletes are estimated to be between 90 and 110 milliliters at rest and a whopping 150 to 220 milliliters during cardio training. Men in general have larger stroke volumes than women because of a larger sized heart, and individuals who are fit also have a larger stroke volume. So for instance, let's say we have two ladies that are both around the same size and age. But Katie here works out regularly and Jessica here does not. Both are required to walk a mile at a relatively fast pace. During each of their walks, we would see that Jessica's heart rate would be higher than Katie's. This is in part because Katie does work out regularly, so her stroke volume is greater. She is pumping more blood to her muscles with each heartbeat than Jessica is. At the end of their walks, we may find that both ladies have pumped the exact same amount of blood, but Katie has done it with far fewer beats of the heart. There is a point where stroke volume of the heart maxes out. At a very high heartbeat, stroke volume may actually decrease due to the shortening of time for the heart to fill with blood. And that be the basics on stroke volume of the heart.
Okay, I hope you've learned some of the important areas mentioned in this video clip, like how to measure your stroke volume, your average stroke volume at rest and during exercise, and the different amounts of heartbeats between a trained person and an untrained person. And now, let's talk about the benefits of regular exercise to decreasing resting heart rate. Regular exercise helps decrease resting heart rate. What does a resting heart rate means? What does a resting heart rate means? Your resting heart rate, or RHR, is the number of times your heart beats per minute while at complete rest. Your resting heart rate is the number of times your heart beats per minute while at complete rest. It is an indicator of physical fitness, as your resting heart rate will decrease as your heart becomes stronger with aerobic exercise training. So a normal resting heart rate for adults ranges from 60 to 100 beats per minute. So generally, a lower heart rate at rest implies more efficient heart function and better cardiovascular or heart fitness. A well-trained athlete might have a normal resting heart rate closer to 40 beats per minute. Okay, the question is, how do you measure your resting heart rate? To measure your resting heart rate, you have to check your pulse at your wrist. Place two fingers between the palm and the tendon over your radial artery, which is located on the thumb side of your wrist. When you feel your pulse, count the number of beats in 15 seconds. Multiply this number by 4 to calculate your beats per minute. So, I want you to watch this second video clip here to help you understand more about the heart rate and how to measure it.
What is a healthy heart rate? Well, heart rate is the number of times your heart beats in a minute. It is measured in BPM, or beats per minute. A healthy normal resting heart rate is usually between 60 and 80 beats per minute. The resting heart rate of a woman is usually about 10 beats more per minute than that of a man in the same age range. And elite athletes can have a resting heart rate as low as 40 beats per minute. This is because individuals that are fit have a larger stroke volume of the heart. Stroke volume is the amount of blood ejected from the heart per beat. So the heart of someone who is really fit does not need to beat as many times to have the same output of blood as an unfit person. Another thing that has a major effect on heart rate is stress. During stressful situations, the body releases the hormone adrenaline, which causes an increase in heart rate, which is beneficial when you're in danger, but unhealthy in everyday situations. When you're sitting and resting, your heartbeat will be lower, and as you start to move around, your heartbeat will increase. When you exercise, your heart rate will vary, depending on the intensity of the exercise, your age, the position your body is in, standing versus lying down, your current fitness level, the type of exercise you are performing, and the temperature and humidity that you're in. Medications can also have a dramatic effect on heart rate. As we get older, our maximum attainable heart rate decreases. There is a simple equation that is used to estimate a person's heart rate max, 220 minus your age. So for instance, for a 35-year-old person, the equation would be 220 minus 35, which equals 185. So their max heart rate should be somewhere around 185 beats per minute. That would be at full physical exertion, like sprinting all out. There is some margin of error for estimating heart rate max, so this number will give you a general idea. There are many training devices that will gauge your heart rate throughout your day and exercise sessions, or you can do it the old-fashioned way. Put the tips of your fingers on the blood vessel on the thumb side of your wrist. Use a timer on your phone and count the number of beats for 10 seconds. Then take that number and multiply it by 6. For example, I counted 11 beats, so 11 times 6 is 66. That means my resting heart rate is at 66 right now. And that be the basics on heart rates.
I hope you have learned some of the important things mentioned in this video clip, which is how to measure your resting heart rate, the difference RHR or resting heart rate for a man and a woman and an athlete, and factors affecting your heart rate and the type of devices used to measure your heart rate. Thirdly, regular exercise helps increase the size and strength of the heart. Your heart is a muscle, just like your bicep muscle. The more you work your heart, the bigger and stronger it gets. Over time, your heart works more efficiently and can push out a greater volume of blood with every beat. So as you begin to exercise, your heart will contract faster and circulation is increased, which gets oxygenated blood to your muscles. So as the demand for blood increases, the heart is going to try to meet the demand by increasing the heart rate and also by increasing the force at which it contracts. So the increase in oxygen delivery is twofold. Your heart will have more beats per minute and a more forceful contraction each time it beats, so it can pump a greater amount of blood throughout the body. The second part of our lesson is discussing the effects of exercise to the lungs. Research states that exercise helps lungs take in and distribute more oxygen. But before we move on to that, a question that comes to mind is, how does gas exchange occurs in the lungs? How does gas exchange occurs in the lungs? Gas exchange takes place in the millions of alveoli in the lungs and the capillaries that envelop them. As shown in the given diagram, inhaled oxygen moves from the alveoli to the blood in the capillaries, and carbon dioxide moves from the blood into the capillaries to the air in the alveoli. Okay, I want you to have a look at this third video clip here to help you understand more about gas exchange in the lungs.
Gaseous exchange refers to the process of oxygen and carbon dioxide moving between the lungs and blood. Air passes into the lungs via bronchi, bronchioles, and then into alveoli. This is where gaseous exchange takes place. Alveoli are individual hollow cavities contained within alveolar sacs or ducts. There are approximately 3 million alveoli within an average adult lung. They have very thin walls, which permit the exchange of oxygen and carbon dioxide gases. A network of small blood vessels called capillaries, into which the inspired gases pass, surrounds alveoli. Diffusion occurs when molecules move from an area of high concentration to an area of low concentration. This occurs during gaseous exchange because the blood in the capillaries surrounding the alveoli has a lower concentration of oxygen than the air in the alveoli, which has just been inhaled. Because both alveoli and capillaries have walls which are only 1 cell thick, this allows gases to easily diffuse from one to the other. The same happens in reverse with carbon dioxide, CO2. The blood in the surrounding capillaries has a higher concentration of CO2 than the inspired air. Therefore, CO2 diffuses the other way, from the capillaries into the alveoli, where it can then be exhaled or breathed out. We can see the results of gaseous exchange from comparing air we breathe in with the air we breathe out.
Okay, what about the effects of regular exercise to the blood? There are a number of regular exercise benefits to the blood. The first one is it helps increase the oxygen carrying capacity of blood. The first one is it helps increase muscle blood flow. During exercise, the increased demand for oxygen is met by increasing muscle blood flow. So the increased blood flow raises the oxygen levels in your body. This helps lower your risk of heart diseases such as high cholesterol, coronary arteries disease, and heart attack. Second one is exercise helps increase your blood volume. The expansion of blood volume that accompanies physical activity provides advantages of greater body fluid for heat dissipation or sweating, as well as larger vascular volume for greater cardiac filling and cardiovascular stability during exercise. And the third one is that exercise or regular exercise also helps increase the number of oxygen and red blood cells in the body. Someone might ask a question, and that question is, what is red blood cells? What is red blood cell? Red blood cell is a type of blood cell that is made in the bone marrow and found in the blood. Red blood cells contain a protein called hemoglobin, which carries oxygen from the lungs to all parts of the body. The meaning of red blood cell is given there. Now let's talk about the effects or benefits of exercise to the blood vessels. Firstly, regular exercise also helps increase the number of blood vessels. The picture of human blood vessels is given. So exercising muscles needs more, and in response to regular exercise, they actually grow more blood vessels by expanding the network of capillaries. And in turn, muscle cells boost level of enzymes that allow them to use oxygen to generate energy. So if you continue to exercise, these stem cells help the body adapt to the stress by building new blood vessels and strengthening muscles. But to maintain such benefits, you must exercise regularly. Secondly, regular exercise also helps blood vessels expand. When you exercise, the blood vessels expand and able to allow massive increase in blood to your muscles. Okay, we're going to do a quiz exercise to help test your knowledge and understanding of today's lesson. There are about 10 questions in a quiz, and the first question is a knowledge question. What is the formula when measuring the heart stroke volume? What is the formula when measuring the heart stroke volume? I want you to think of one of the slides that we discuss the human heart stroke volume? Okay, let's have a look at the answer. The answer is EDV minus ESV equals SV. End diastolic volume minus end systolic volume equals stroke volume. The next question is, what is another name for cardio? What is another name for cardio? Okay, let's have a look at the answer. Another name for cardio is heart. The next question is, name the two organ systems that made up the cardiorespiratory system of the human body. I'll give you 30 seconds to think of the answer. Okay, let's have a look at the answer. The first organ system is the cardiovascular system, or the heart and blood vessel. The second is the respiratory system, or the lungs. So the cardiovascular system and the respiratory systems made up the cardiorespiratory system of the human body. The next question is a knowledge question. What effect did exercise have on your heart rate? Mantua foi tamai ti elza to video clip le sa mata. Taimi o fire tato le sona. Le sa fatalo inai le resting heart rate. Malona ese senga pe a le fire se tolninga. Ia pe malo lofo. O inai tau na mo mai sautali. What effects did exercise have on your heart rate? Okay, let's have a look at the answer. Exercise helps decrease your resting heart rate. Exercise helps decrease your resting heart rate. How do you think this happened? How do you think this happened? That is our next question. And this is a follow-up question that helps test your skills of understanding and application on the process of how exercise lower your resting heart rate. Okay, how do you think this happened? So, in other words, how do exercise decrease your resting heart rate? So, I'll give you 30 seconds to think of the answer. Okay, let's have a look at the answer. Exercise creates pressure to the heart and enables it to have a higher level of cardiovascular fitness. So during exercise, the heart increases its size and strength and also increases the volume of blood that pumps to parts of the body during each beat. So when your body is rested, the heartbeat is getting slower because it is fit enough to pump more blood to the body in one beat. Okay? I hope you understand how the exercise helps decrease your heart rate. The next question is, how do you measure your resting heart rate? How do you measure your resting heart rate? This is also a knowledge question. Okay, let's have a look at the answer. To measure your resting heart rate, you need to check your pulse at your wrist. Place 2 fingers between the bone and the tendon over your radial artery, which is located on the thumb side of your wrist. When you feel your pulse, count the number of beats in 15 seconds. Multiply this number by 4 to calculate your beats per minute. The next question is, what effects did exercise have on your lungs? What effects did exercise have on your lungs? The answer would be, the exercise helped the lungs take in and distribute more oxygen. Exercise helped the lungs take in more. Exercise helps the lungs take in and distribute more oxygen. Okay, the next question is a definition question. Define the term red blood cell. Define the term red blood cell. Remember the slide that we discussed the benefits of exercise to blood vessels. Okay, let's have a look at the answer. A type of blood cell that is found in the blood. Red blood cells contain a protein called hemoglobin, which carries oxygen from the lungs to all parts of the body. Our next question is, which of these is true about the benefits of exercise to the blood? Which of these is true about the benefits of exercise to the blood? A. Increase muscle blood flow. B. Increase blood volume. C. Increase the number of red blood cells in the blood. And D. All of the above. Okay. That is a multiple choice question. And I'll give you 30 seconds to think of the right answer. Which of these is true about the benefits of exercise to the blood? A. Increase muscle blood flow. B. Increase blood volume. C. Increase the number of red blood cells in the blood. And D. All of the above. Okay, the correct answer is D. All of the above. And our last question is, state any two benefits of regular exercise to the blood vessels. State any two benefits of regular exercise to the blood vessels. Try and think of any two benefits of regular exercise to the blood vessels. Just think of the role of blood vessels into your body. Okay, let's have a look at the answer. The first one is increase the number of blood vessels. And the second one is the blood vessels expands or increase in size. Okay, that is the end of our quiz, and I hope you understand more and testing your knowledge, understanding, and application skills through this quiz activity. That is the end of our lesson for today. Before our lesson concludes, I know some of you really want to know the kind of exercises that helps improve the health of your cardiorespiratory system. As you may be aware, there are a lot of exercises that you can do it while you're staying at home. For example, you can do exercise like doing press-ups and sit-ups for 30 minutes. You can also do Zumba for 30 minutes. Or you can do your normal chores now. To conclude our lesson, I will leave you with this normal exercise that can help improve the health of your lungs. You will be better